All right, so EV7 feels almost identical to LE4 in terms of we are just writing on a solution to a system of equations. It's just a homogeneous system where all of those solutions on the right-hand side are zero, which makes it easier. In fact, if you need to, you can walk through rewriting the reduced row echelon form of the augmented matrix back as a system. So that would be this, and x2 minus x3 is equal to 0. One situation I was seeing is students getting distracted by the fact that we had 5 equations as opposed to paying attention to the fact that we have 3 unknowns, right? So if we were solving this system of equations, we're going to end up with a solution space, right, or a solution that has 3 components, an answer for x1, an answer for x2, and an answer for x3. So this should already let you know that our solution is going to look something like this in terms of what we're going for, right? Of course, written as a set as we've been practicing, but I saw a handful of students write this as a 5, right, element column vector, a 5 by 1 column vector, which is just not where we wanted to head. If we wanted to, we could move through, okay, we have our lovely free variable here, this x3. We could go ahead and define that as some variable, which means x1 is equal to -2 of that t, and x2 is equal to t. Many of you probably, we've done enough of these that you didn't have to do that. You just changed the signs on that free variable as you moved it over. But now we have our column vector for that solution set. We need it to be -2t, a t, and t. And again, I'm seeing a lot of students, another situation I'm seeing is forgetting the actual free variable, forgetting that we defined x3 as t. That also needs to be in this column vector, right? And then we have multiple ways we could write that. We could write this in the form that we probably used for LE4 back in the day. We could go ahead and rewrite this. Not a very exciting way to rewrite, but as a scalar multiple times that vector. Or now that we've written that down, that really makes it obvious that we're talking about all of the linear combinations. There's not really a combination here because we only have one vector. So the span of that vector, -2, 1, 1. So all of these are equivalent. It was just a matter of which one you wanted to write out. And then that span really is the most useful. These other 2 formats, I think, are the most useful for when we move to the basis, which is that set of vectors that would span this space. And so, if I already have that, I just need to write out that one single vector in this case as my basis for this solution space. Again, I think students got distracted. A lot of students, not a lot, but more than I expected, came in here and saw the word basis and just like defaulted to whatever the hex section that was. I don't remember anymore. And went, ooh, I have 1 and 1, which means I need one of these guys. Right, that would be like something else entirely. In this case, that's not what we're going for. We wanted the basis of the solution space. So you got distracted by the word basis, jumped into some sort of procedure you had learned, but we're talking about the basis for the solution space. So we're up here looking at this space that we already wrote, not back at that system of equations or the vector equation, right? We were never given a set of vectors and asked about it, which is where you went. Was if this was a set of vectors, sure enough, but it's not. We're at a very different situation. So you got to constantly kind of keep your head on a swivel in terms of what the context is for what we're doing in this class.